Welcome to the Ducks Unlimited podcast, the only podcast about all things waterfowl. From hunting insights to science-based discussions about ducks, geese, and issues affecting waterfowl and wetlands conservation in North America, we bring the resource to you. The DU Podcast with your host, Dr. Mike Brazier.
In North America, we are blessed with a rich diversity of waterfowl populations and waterfowl habitats, and we've been quite successful over the years in effectively conserving them. But in many cases, the road to those successes have been long and arduous. They have required creative solutions. They have required tremendous partnerships, some of which that while productive in the end have been sometimes uneasy along the way. And it continues to require navigating a seemingly never-ending labyrinth of detours and unexpected collisions to continue on with our roadway analogy. On the next couple of episodes, we're going to be talking about one example that in current times in particular exemplifies in great fashion this long road and the persistent challenges that waterfowl populations and their management continue to encounter. This conversation takes us out west to an area that has been described by many people as being, at one time, the most important region for migrating waterfowl on the planet. Things have certainly changed since the days of those early descriptions, and that's what we're here to talk about. That place is the Klamath Basin in southern Oregon and northern California. To give us firsthand information and insight on this place, its importance to waterfowl, and all matter of historical and current developments, including an eventual discussion about avian botulism to boot, are two people that know this region very well. Dr. Dave Mauser, retired U.S. Fish and Wildlife Service supervisory biologist for the Klamath Basin National Wildlife Refuge Complex, and Dr. Mark Petrie, Ducks Unlimited's Director of Conservation Planning for the Western region. Dave, welcome to the podcast, and thanks for taking the time to join us.
Well, thank you for having me, Michael.
And Mark, welcome back to the podcast. You were an episode on an earlier episode, but it's good to reconnect with you.
Glad to be back, Michael.
Dave, let's start off with you giving our listeners a background on your professional career. I mentioned at the outset that you are now retired, so congratulations on that. But to give people an idea of where you come from and your credibility to speak on this topic, let's do a bit of an introduction.
Oh, okay. Well, without getting too long-winded, I got my wildlife degree, my bachelor's at Humboldt State University, and a master's at the University of Wisconsin in Stevens Point, and a doctoral degree at Oregon State University. I retired 7 years ago with 32 years with the federal government. 22 of those years were as biologist at Klamath Basin National Wildlife Refuge. And I started there in my temporary days, even before I started working full-time there in the late 70s on some steel versus lead shot studies on the refuge, and working on various refuge maintenance projects as a biological technician. I started working there full-time in 1991 or 92, early 90s, about the time that the first biological opinion came out. But anyway, I was at the refuge as a biologist for 22 years.
Dave, the other thing that I found out about you whenever I was doing my research leading up to this is that you were the 2011 National Wildlife Refuge Employee of the Year. So let me say, 9 years belated. Congratulations on that very deserving award.
Oh, thank you. Yeah, that was very unexpected, but appreciated.
Yeah. And Mark, as I mentioned, we've had you on an earlier episode, but let's give another introduction of you and your professional background and what it is that you do for Ducks Unlimited.
Sure, Mike. I'll keep it pretty brief because I've been on before, but I've been with DU 24 years now, I think. The first 5 years I spent at national headquarters in Memphis, Tennessee as a research scientist there. And then about almost 20 years ago, I transferred out west to our Western Regional Office, which is in Sacramento, although I'm in our field office here in Washington. And I mostly work on the science and conservation planning side of things, and mostly or almost exclusively on wintering waterfowl. So obviously the Klamath Basin is very much of interest to me.
And I appreciate both of you taking the time to join us here. I know y'all have worked together for a number of years on this very topic, and I'm excited to hear about this from you guys. I've read a fair bit about the situation out there. I've never been to that region. I think we actually had Amelia Raquel on an earlier episode as well, talking about some of the work that she does out there. So I've picked up some understanding of the issues, but I certainly don't know them the way you guys do. And it's such an important area for waterfowl. And there are some things that have happened, very recent relative to the timing of this podcast, but then also over the past year, that bring additional importance to the situation in the Klamath Basin. And waterfowl conservationists, waterfowl hunters across North America should be interested in this story. And so we're happy to bring it to them here. And, whenever we talk about areas or regions where there are some significant waterfowl habitat conservation or waterfowl population challenges, a full appreciation for those challenges as they exist today oftentimes requires us to go way back, oftentimes way back to European settlement of North America and how things developed through the years, because all the things that happened back then in many cases sort of shaped the landscape and the challenges that we have today. And as I've been exposed to a number of stories, a number of regions that are important for waterfowl and where we do a lot of conservation work, where we have a lot of challenges and where we are trying to deliver innovative solutions to those challenges. And I'm not sure if I've come across one where the situation is as complex as what is happening and has happened in the Klamath Basin. I did some research leading up to these episodes, and this story is going to obviously involve waterfowl habitats of different types, fish, both anadromous fish and freshwater fish, inland freshwater fish. It involves some Native American interests, some agricultural interest, irrigation districts, water rights, numerous pieces of federal legislation, one of which is the Endangered Species Act, multiple cabinet level departments and their agencies, lawsuits, and 2 states are involved, numerous stakeholder groups. So the list goes on. And like I said, this is a really important story. It's a really important region, and what's happening out there is certainly a priority for Ducks Unlimited and a lot of our other conservation partners. So we wanted to bring this important story to people. So with that sort of long-winded introduction, I want to start turning the questions over to Dave. And I think where it's important to start for people that may not be familiar with the Klamath Basin, is to give us some sort of the geographic and ecological setting of the Klamath Basin. And Dave, you can approach this however you want to, sort of speaking in where is it, and then kind of what it looked like historically in terms of the wetland communities there. But for those that may not be familiar with it, give us an introduction geographically and ecologically to the Klamath Basin.
Oh, wow. Well, the Klamath Basin, of course, encompasses a very large area from the headwaters of the Klamath River in Oregon clear down to the Pacific Ocean in California. The upper part of the basin, what's called the upper basin, is the river is sort of backwards. Mostly in mountainous areas, the upper watersheds are steep, and the lower watersheds, you start to lose some gradients and things become flattened. And in the Klamath, it's backwards. The upper watershed sits on a high plateau, the upper basin, about 4,000 feet. And that's where your lakes and marshes historically were, about 350,000 acres of lake and marsh. And then when you get downstream of that 4,000-foot upper basin, then you get into more riverine, steeper canyons, and heavily forested habitats that you sort of envision for the Pacific Northwest. That's, of course, where your largest salmon and anadromous fish resources are. But in the upper basin, about 350,000 acres of freshwater wetlands. Principal ones were Upper Klamath Lake and associated marshes. Of course, Tule Lake and Lower Klamath Lakes. Other Sycan Marsh, Klamath Forest Marsh, just a whole host of very large inland marshes in the upper watershed.
Dave, you said, I think you referenced maybe historically 350,000 acres of wetlands. What kind of wetland wetland systems are we talking about there? What's the source of water for those wetlands?
Well, the wetland sources of water were pretty much creeks and streams, and of course runoff. Snow melt is higher elevation, so snow melt and spring filling of the wetlands were very important. Probably 50% of the upper basin wetlands were seasonal historically. In other words, would dry out at some period of time during the summer, and then reflood with fall rains or the melting snow in the winters.
And in terms of the historical vegetation in those wetlands, are we talking about like cattail marshes, bulrush marshes, or some other, probably in the seasonal wetlands, seasonal components of those, probably not, but in some of the more semi-permanent, is it going to be like a cattail marsh type of setting?
More hardstem bulrush, some cattail, a lot of other sedges and burr reed, water lilies, what they call wokus here in the upper watershed, in the deeper areas.
Okay. I just like to give people a bit of a mental image on these areas because there are a lot of our listeners, certainly east of the Rockies, that are not going to be too familiar with those. And this is another one of those times where I will encourage people, if they're listening to this in front of their computer, or even if you're listening to it in your vehicle, once you get home, you pull up Google Earth or Google Maps and go out, navigate out there to this region. You can, I'm sure you could Google Upper Klamath Lake, Lower Klamath Lake, or Teal Lake, and it will take you right to that location. You should be able to find the Klamath River. But developing a mental image of that region oftentimes helps in visualizing this story and all the pieces to it.
The wetlands, historic wetlands in the upper basin individually were really large. I mean, 10 to 20,000 acres in a single marsh was not uncommon. Very, very large wetlands.
Dave, I think, Dave, is it fair to say that a lot of that country is high desert? A lot of the upper basin is high desert. And so I think in some ways these are very much kind of waterfowl oasis in an otherwise very arid landscape.
Yeah, essentially the Klamath Basin sits right on that ecotone between the deserts on the eastern Oregon, east of the Cascades, and then the wetter Cascades directly to the west. So, yeah, a lot of the upper basin is fairly arid, or drains a fairly arid area.
From an ecological standpoint, I referenced at the introduction that this place is oftentimes referred to, or at least in the past has been referred to, as possibly one of the most important areas on the planet for migrating and wintering waterfowl. Dave, speak to that a little bit in terms of where this region sits and its importance to waterfowl in the Pacific Flyway.
Well, of course, it sits in between the breeding grounds in Alaska and Western Canada, and the northwestern states, and the wintering areas in Central Valley of California and on into Mexico. It was sort of equated, if you consider the migration coming down the Pacific Flyway, the Klamath Basin was like the hourglass between those northern, more dispersed breeding areas and the southern wintering areas. And some of the numbers are fairly astronomical. When they really began taking good surveys of the birds in the 40s and 50s, there's records of up to 7 million birds at one time, just on the two lower refuges, Teal Lake and Lower Klamath. So some of the numbers were astronomical.
Dave, to my knowledge, I've looked at those numbers too. 6 to 7 million birds was not uncommon on those two refuges. And I can't think of anywhere else on the continent that we would have ever seen those kind of duck densities during fall or winter. I'm not aware of them if they existed.
Yeah, absolutely. And it was such a phenomenon that I think there was even stories in Reader's Digest and Life magazine about the wildlife spectacle that was there in the 1950s.
In terms of some of the principal waterfowl species coming through there, obviously pintail comes to mind because of its importance to the Pacific Flyway. What other waterfowl species? And we could even say historically, and I don't know if the species composition has changed through time, but what kind of waterfowl species are going to be most prominent there?
Well, if you talk about big numbers in the 50s, pintails dominated were probably 85 or 90% of the birds. And then the other species were also there, the similar species you see there today, just in more abundance than you see today. One thing that Klamath Basin gets overlooked for is the number of diving ducks that stage in the basin, particularly the canvasbacks that we used to see on Lower Klamath and Teal Lake.
What about its importance as a historical breeding area for maybe cinnamon teal or any other species? Do we have any records of that? Did it serve as a breeding region?
Oh, absolutely. That's the interesting thing about the basin. It's both a breeding area and a migrational area. And so when it comes to, I'm getting maybe ahead of myself, but when it comes to managing the wetlands on Tule Lake and Lower Klamath, you have to keep in the back of your mind that I need these seasonal marshes for the migrants are coming, but I also need water through the summer for the waterfowl production that's also occurring that is significant, along with the other host of other water bird species that were on the refuge.
We have the ecological and geographic setting for the region, and we want to now talk about the era of kind of human settlement of that region and some of the important legislation that began to affect the area and shape the land use through the 20th century, and certainly takes us to, as responsible in large part for the landscape that we have there today. So take us back to the turn of the 19th century and what was happening, what kind of settlement opportunities were occurring, and then, what happened in the Klamath Basin to set us on the path that we followed for the past 100 years?
Probably the first thing of legislative significance that happened was that the federal government passed the Swamp and Overflow Lands Act in the middle 1800s, which allowed, transferred title of wetlands and overflow lands from the federal government to the states, that the states could then sell to raise money to theoretically reclaim these lands for agricultural use. So that was the first thing that happened, and that allowed early homesteaders or early people settling the land to place claims on some of those big wetland areas. A classic one would be the northern half of historic Lower Klamath Lake. About 25 or 20,000 acres were in private ownership by the time the refuge was even established, Lower Klamath. So there was early attempts to settle the basin, and in about 1880 or so, there started to be the first private works of irrigation in the Upper Klamath Basin. And that ultimately led to roughly 10,000 acres being irrigated before the turn of the century. And I think what happened after that point was, I think the early people that had speculated that these lands would ultimately be drained by somebody with a deeper pocket than the local folks had. That was an invitation really to get the federal government involved, and the Klamath Project came to town in the Bureau of Reclamation in the early 1900s to look at the feasibility of reclaiming the historic marshes and lakes in the Upper Basin. And the Klamath Project really had its eyes set on, the four key components of the Klamath Project were Clear Lake, Upper Klamath Lake, Tule Lake, and Lower Klamath. So what they were really trying to do is, they were pretty much, the local people, they needed a deep pocket to develop something that big. So anyway, the project started, was authorized under the 1902 Reclamation Act, was authorized, the Klamath Project was authorized in 1905. And there was a lot of engineering that went into that before it happened. And I will say there was sort of three components to the early reclamation thinking. The first was Clear Lake, the Clear Lake area. The second was the Tule Lake area. And the third was the Lower Klamath area. But the number one priority was definitely the Tule Lake area. I think that's where the feeling was that the land values for agriculture were the highest.
So, Dave, basically what we have happening here is an early piece of legislation that was the Reclamation Act that was trying to facilitate irrigation and development, agricultural development, you might say, of some of those portions of the West. And Mark, did that piece of legislation carry into other places out West in California, perhaps?
Right. I'm pretty sure it did, Mike. I think a lot of the irrigation, a lot of the federally sponsored irrigation in the Central Valley was also born under the Reclamation Act. So it had a really, really wide impact throughout the West in terms of really bringing water to the desert, if you will.
And the Klamath Reclamation Project the Klamath Project was one of the first projects authorized under the O2 Act. And so, at the turn of the century, people's thinking about wetlands were not as diverse as the thinking is nowadays. And mostly wetlands were thought about as mosquito breeding swamps that needed to be put to better use. And so the Reclamation Act, or the Klamath Project, was authorized as a single purpose project. And that was for development of the land for irrigation and agricultural use. And that's a point that in a matter of law that is with us even today in 2020.
And so, Dave, that necessarily brings with it some, quote, reclamation, or, a more direct term would be sort of drainage, or the reducing of the size of some of those wetlands in the interest of agricultural development. And so from my reading, this was a pretty interesting time back then, because you had one interest in agricultural development and development in general, settlement of that region and enabling people to make a livelihood. And then somewhere along the way, people began to realize that, hey, wait a minute, there are other ecological values associated with these wetlands, and it's something we might want to consider. And so not too long after the Reclamation Act, if my reading is correct, there was, I guess, the establishment of one of those first refuges out there. So talk about how that unfolded as we understand it, in terms of, on one hand, we have some development and sort of reducing the size of these wetlands. And then on the other, we have recognition of the need to kind of preserve some of these wild wetland areas.
Yeah, almost concurrently with the first Bureau of Reclamation engineers coming to the basin to size things up and look at the feasibility of reclaiming the lands. Early conservationists were also, principally William Finley, a famous photographer with the Oregon Audubon Society, famous photographer who was really documenting the early wildlife use. So you had those two things going on at one time. And William Finley's photographs that he took, and his personal relationship he had with Theodore Roosevelt, he was able to get Theodore Roosevelt to pass via executive order, or he established via executive order, the Lower Klamath National Wildlife Refuge in 1908. And again, notice that the project started in 1905, the Reclamation Project, and the refuge was established in 1908, 3 years after the project was initiated. And that's reflected in Teddy Roosevelt's executive order, which basically says that, quote, all lands deemed unsuitable for agriculture are hereby dedicated to wildlife conservation, et cetera, et cetera. So even Theodore Roosevelt's executive order establishing the refuge recognized the prior claims to the land for reclamation purposes.
And of course, Mike, a lot of that probably depended on whose definition of what was farmable and what wasn't. And that probably created some of the confusion early on that, to some extent, probably with us today.
Yeah. So if I understand correctly here, then, let me just ask it this way, Dave. Was there any type of boundary associated with the establishment of that refuge? It doesn't really sound like it was, other than within the Klamath Basin. How did that work?
Yeah, there was a boundary around the original reservation in 1908 via Teddy Roosevelt's executive order. It was in the neighborhood of 85,000 acres. It occupied the bed of the historic lake. And the historic lake was pretty much comprised of about 35,000 acres of open lake, and then the surrounding areas around it were all dense emergent marsh. But even though and what was difficult was that the refuge established the entire lake bed, but the northern roughly third had already been patented to individuals under the Swamp and Overflow Land Act of the mid-1850s. Or mid-1800s. So things were complicated from the very beginning.
I have to think about the irrigation project this way too to help me understand it. But it's like it wasn't just about bringing water to the desert to irrigate. It was also about draining those lakes for agricultural purposes. when we think about an irrigation project, we think about bringing water somewhere. But this irrigation was also about getting water off places, and those two places were Tule Lake and Lower Klamath Lake.
Yeah, that was hugely important, because I think it was viewed that those lake bottoms were probably some of the most productive soils in the basin.
So Lower Klamath was established in 1908. Then I know we've also talked about Tule Lake National Wildlife Refuge. When was it established? And is there what kind of association is there between these two refuges?
Tule Lake was established via executive order. I believe it was Calvin Coolidge in 1928. It was, I forget how many, maybe it was around 15,000 acres initially. It was quite a bit smaller than it is now. But Tule Lake historically was separate than Lower Klamath. It was in a closed basin fed by the Lost River, which started up in Clear Lake. And so anyway, and what would happen is that Tule Lake was a very dynamic lake, kind of like a lot of the lakes in the Intermountain West that are very much influenced by high years of precipitation and drought periods. So it would reach a maximum size of, say, 110,000 acres, 46 feet deep, feathering out into marshlands on the periphery. Would hold at that level, it would hold over 2 million acre feet of water. I mean, it was big. And it would shrink down as low as 30 or 40,000 acre feet or acres during periods of drought, and maybe 7 feet deep or so at a maximum level. So some of the principal means of draining Tule Lake was Reclamation built a dam on Clear Lake, which is the headwaters of the Lost River, to shut off the inflow to Tule Lake. And then what Lost River flow did make it down to the basin, headed toward Tule Lake, they built a diversion canal and shunted that water over to the Klamath, if that makes any sense.
Yeah, I think so. Anytime we get into these conversations about irrigation districts and irrigation projects, there's a high degree of engineering that occurs. And so sometimes it might be difficult to get a full mental picture of what's going on. But nevertheless, the point is it became a highly altered, highly engineered landscape with regard to the conveyance of that water, conveyance and control and allocation of that water. Dave, there's also the Upper Klamath National Wildlife Refuge. When was it? And I don't think we've talked much about the Upper Klamath Lake yet, but what about that Upper Klamath Lake Refuge, and when was it established?
It was also established in 1928, also by Calvin Coolidge. And the marshes on Upper Klamath Lake they're not diked off from the lake itself, so they're subject to whatever lake level is at, dictates whatever water depth are in those marshes. There's two units to Upper Klamath right now, the Upper Klamath Marsh at the north end of the lake, and then Hanks Marsh, about 1,000 acre piece down at the southeast corner.
Okay, so we have the irrigation project underway. I actually, I think I saw something where it began, the Klamath irrigation project got underway, what was it, 1906 or 1908, something like that, Dave?
Yeah.
And then it wasn't officially completed until maybe 1960 or something of that nature, to give people an idea of how long that it was in the works. Do I have that right?
Yeah, that's about right. It was a work in progress from starting in 1905, and it took time. And there's a different story. There's a different story for how Lower Klamath Lake was drained and how Tule Lake was not really drained, but allowed to evaporate. And ultimately, Tule Lake and Lower Klamath were linked together by the deep planted tunnel through Sheepy Ridge, which connects the two. But that's another story there. I'm not sure we're there yet.
Mike, I'll just a note about Upper Klamath Lake. We were talking about Upper Klamath Lake Refuge a moment ago, and it also serves as the main reservoir for the Klamath Irrigation Project, which becomes pretty important to our story a little later on, in terms of how ultimately that lake was allowed to be managed in terms of supplying water to the irrigation project. But and as far as reservoirs go, it wasn't a great one. It's a very large lake, but the problem is it's also very shallow. I think, Dave, it's maybe 8 feet at its deepest, I think I recall.
And that's pretty much its average depth. Yes.
Yeah. And so the problem is then when you did get wet years, the lake doesn't have a lot of capacity to store all that extra water to kind of hedge against drought conditions. So
yeah, essentially the Bureau of Reclamation and the water users here, they consider their storage is that snowpack in the mountains. What's going to come off gradually through the summer to feed the irrigation system, the lake and the irrigation system. Yeah, you're right. There isn't much storage in the lake. But management of that lake, of course, for irrigation purposes, has a big effect on those marshes around the lake.
Dave, that point about snowpack is probably a good one to emphasize. I don't think we had touched much on that yet. And snowpack being the primary source of water for that region is obviously worth pointing out. I do think it is important, Mark, and thank you for doing that, to kind of clarify the role that Upper Klamath Lake plays in the Klamath Irrigation District. So what about Clear Lake? And you mentioned it, Dave, but I want to make sure I'm clear, to use that word, on its role as a source of irrigation water, if it is.
It was originally built. They put a dam on Clear Lake. It was originally a lake with a small marsh associated with it, and had some good wildlife values. And one of the first things the Bureau did, it's on the Lost River. They built a dam at Clear Lake to hold the Lost River water back in the upper watershed so it would not reach Teal Lake, because they were trying to drain Teal Lake. And now downstream of the Clear Lake Dam, there's several irrigation districts that are now dependent upon the waters from Clear Lake for irrigation purposes. So yes, Clear Lake is now, it's a national wildlife refuge under the Fish and Wildlife Service, but the water is managed by the Bureau of Reclamation.
Okay, we have irrigation development occurring in the basin. We have a series of national wildlife refuges that have been established. I'm kind of thinking here in the late 20s into the 30s. And what other significant events take us up to the 1950s? I know there are some things that occur in the 1950s that we want to spend some time on, and then in the 1960s, I think, perhaps, if I'm getting my dates right. But what else would have happened in the intervening years that we need to know about here before we wrap up this particular introductory episode?
Oh, well, of course, probably the biggest event that happened in the 20s and 30s, Lower Klamath Refuge was established in 1908. The Bureau of Reclamation signed a contract with the Northern Pacific Railroad, which the Northern Pacific Railroad was going to build a railroad embankment across the north end of Lower Klamath Lake and Marsh. And the Bureau came up with a contract in 1907 for the railroad company to also put in a water control gate on that embankment, which would allow Klamath River water to not reach Lower Klamath Lake anymore. And essentially, when they closed those gates finally in 1917, it took about 3 to 5 years, but the entirety of Lower Klamath Lake dried up in the 1920s and 30s. And it was a huge problem for the basin because the lake and marsh had about a 2 or 3 foot layer of peat on top of the parent material underneath. And so when you expose those lands to the air, to the desert air, they caught fire if there was any kind of a spark, and they would burn literally for years, and the ash would blow, and it was a tremendous nuisance to the local community, not to mention, of course, the giant loss to the wildlife resources that used to live there. Now, in the 20s and 30s, on the other side of the Sheepy Ridge to the east, where Teal Lake is, the Bureau had successfully shunted the Lost River water from Clear Lake over to the Klamath, shutting off the source for Teal Lake. But what was happening is, as they developed the Klamath Irrigation Project upstream of Teal Lake, you start to generate return flows from those farmlands. And the return flows from those farmlands end up in the bed of Teal Lake again. And so Teal Lake starts getting bigger again. And it's limiting the ability of reclamation to reclaim the bed of Tule Lake for agriculture. So you have too much water on the Tule Lake side of the hill, and on the other side of the hill you've got Lower Klamath that's bone dry and blowing away. So in 1938, a reclamation engineer came up with an engineered solution to the whole problem, and that was to build a tunnel through the ridge connecting the excess water in Tule Lake to the dry lake bed of Lower Klamath. And so that enabled the rewatering of Lower Klamath and the shrinking in the size of the then Tule Lake. That is the whole. There was the ITIC report, they call it, was the Bureau's report, and then there's a report called the Fairchild report, who was the refuge manager in 1938 at Tule Lake, or Lower Klamath and Tule Lake. And so the service came up with a big plan with what they were going to do if they got the water. And the Tule Lake side, the Bureau of Reclamation came up with their big plan on what they were going to do with the lands on that side. So in general, the Bureau was going to get 20,000 more acres to homestead and reclaim on Tule Lake, and they would be reflooding up to 17,000 acres of the Lower Klamath Lake bed and have more irrigation water for farming over on the Lower Klamath side.
Is that conveyance structure still present and still used?
Oh, yeah. Yes. It's a key component of managing water on the Tule Lake, floodwaters, irrigation waters on the Tule Lake side of the hill.
This is more complex than I ever imagined.
That whole report and the agreements between reclamation and the service explain everything about why the project looks the way it does today, and the whole relationship between water management on Tule Lake and Lower Klamath. You
need an engineering degree to understand some of this stuff.
Yeah, apparently.
It is very complicated. Maybe it took me 22 years there to understand it. I don't know.
Well, again, thank you for joining us here to give us the Cliff Notes version of it and train us up on this. I tell you, it's something. And here it is, an area that is of critical importance to waterfowl, and obviously that's why we're talking about it and wanted to bring this story to people. We've talked a lot about engineering and the specifics of where these lakes are and the drainage districts and sort of the historical development of the situation there. And, eventually we're going to get to the story of what's happening now and how all of those early decisions and early pieces of legislation and all these other aspects of the irrigation structure will come into play. But for now, we probably are at a good place to wrap up this first episode. Like I said, we have a lot more to cover. But Dave, I'm going to ask you and Mark to join us here on another episode, and we'll continue the conversation. And so thank you guys for joining us here on this episode.
Well, thank you, Michael.
Thanks for having us, Mike.
A very special thanks to our guest on today's episode, Dr. Dave Mauser and Dr. Mark Petrie. We greatly appreciate their expertise on this incredibly complex topic, but one that is very important to waterfowl conservation in North America. As always, we thank our producer, Clay Baird, who does a great job editing these podcasts and getting them out to you. And of course, to you, the listener, we thank you for being part of this effort. We thank you for spending your time with us here on this podcast. And we thank you for your support, passion, and commitment to wetlands and waterfowl conservation.
Thank you for listening to this episode of the DU Podcast. Be sure to rate, review, and subscribe to the show, and visit www.ducks.org/DU Podcast for resources based on today's topics, as well as access to more episodes. Opinions expressed by guests do not necessarily reflect those of Ducks Unlimited. Until next time, stay tuned to the Ducks.